today we're going to do another paper 2 paper. I was organizing some stuff for blockers. So right now we still just continue with the calculation, and then after some time I can do the part B's for both videos. Okay, so the first question asks you to simplify 4 minus, and then you have open bracket 1 and 3 by 4 plus 1 and 2 over 3. Okay, so here the trick was in the brackets. So whatever sign is outside the bracket is supposed to be distributed within. So I advise you to actually do this in one step. Okay, so the first step, just distribute in. So you get negative 1 and 3 over 4 here, and then this one you get negative 1 and 2 over 3 here. Okay, so after you've done this, what you do is when sorting fractions, when sorting mixed fractions, you actually have to change them to improper fractions. Always, if you want to process any data, your fractions, it's often easy to just process it into improper fractions first. So here you say 1 by 4, then you get 4, then plus 3, then you get 7. Then here you say 1 by 3, then you get 3, plus 2, then you get 5. 5 over 3, okay. So the next step now, I'm going to use the space. So the next step now is you have to put the common denominator. Okay, so the common denominator is the lowest common multiple for the denominators. Lowest common multiple, which is the common denominator, is 12. Okay, so you say 1 into 12, then you get 12, then you say by 4, then you get 48. Okay, then you say 4 into 12, you get 3 by 7, then you get 21. Okay, so negative 21. Then here 3 into 12, you get 4 by 5, you get negative 20 here. Okay, so from here on, what you can do, you can just simply use a calculator, or if you're comfortable, you can actually just simplify. So here you get negative 21, negative 20, so you get negative 41. So 48 minus 41, you get 7. So 7 by 12. So your answer is actually 7 by 12. Okay, so this is paper 2. So the advantage is you can actually verify your answer. Just type it the way it is right now and then see what comes out. If your calculator doesn't have the functionality to actually put a mixed fraction, just use with this step here. So the B part says y equal to 5.3 and z equal to 4.2, z equal to 4.2. These are corrected to one decimal place. And you asked to find the minimum value of, so the question paper that we are modeling from, it didn't actually have some of the stuff that were not done properly. So now I'm actually going to exemplify for you using y minus z. Okay, the concept is still the same. These are called non-routine questions. It means that you actually have to renew your interest in the question because they usually come differently, and depending on how they come, the concept might be the same, but then the steps that you take to actually get the value, they're usually different. So here you reason, our values for y and z, they've been corrected to one decimal place. So you reason, what was y? Okay, so you cover the whole range. So y can be greater than or equal to what? 5.25, for example. This would be the we call this the lower bound, because any number which is 5.25 and above up to 5.3, these numbers, they can be approximated to 5.3. okay, so the upper bound would be, here you put a strict sign. Why? Because the number that we're going to put here, we're actually not going to include it. Okay, so it's 5.35. So any number less than 5.35, it will be rounded off to 5.3. So you do the same thing for z. So the upper bound, the lower bound. The lower bound must be 4.15. Okay, so the upper bound must be 4.25. Okay, so if you're asked to find the minimum value of y minus z, what you do is you inspect. So y is positive. If you want to make this function here a minimum function, it means the minimum value, you have to choose y which is less. Why? Because for positive numbers, the lesser the magnitude of the number, the lesser the number. Okay, so we'd actually choose 5.25. So here you'd say 5.25, and on this one, now on the Z part, you'd actually choose the highest. Why would you want to choose the highest? Because here you have negative. So to minimize this function, a negative of a magnitude or number, for example, let's say -7 and -100, you'd say -7 is bigger. So for y, we're going to choose the lowest number. So it's 5.25, simply as that. And then for z, we are going to choose the highest size for z. Why? Because if it's a negative value, the greater the magnitude, the lesser the number. Okay, so we want to lessen this function, we want to minimize it. So we have to choose the least number, which would be the greatest magnitude for z. In the same way that I was saying -z and -7 and -100, -7 is clearly the bigger number. If you choose this one, you can think of it as which one should I choose? Should I choose 4.15 or close to 4.25? If you choose -4.15 here, you would get a greater value than if you choose 4.25. Why? Because this is negative. So we would choose 4.25, but 4.25 is not included. So we would actually choose 4.24. This is very important, okay? This is a strict sign, strict inequality sign, so you actually have to round down. So here, I don't know why I wrote this, but I say it 4.24. Why? Because you have to take less. If it's 4.25 exactly, then it gets rounded up, so it actually be 4.3. So now you just punch this on your calculator. So it's 5.25 minus 4.24, 1.01. Okay, so you get 1.01 like this. So 1.01. So you're done. Let's move over to the next question. Next question says, a hotel has executive and general rooms in the ratio 3:5 respectively. A general room costs $19 per day. On a certain day, all the 2,928 rooms were occupied by both executive and general customers. The total takings from the rooms was 66,612. Find the number of general rooms in the hotel. Okay, so you're going to use this ratio. This is called mathematical modeling. You're taking real life data and then you want to make sense of it in a mathematical way. Okay, so here you're told 3 belongs to, for every 3 executive, you have 5 general rooms. So for every 8 rooms, you have 3 executive rooms and you have 5 general rooms. Okay, so if you want the number of general rooms, you have to check that share. So the share is 5 over 5 of every 8. Okay, so 5 of every, the total here. So multiply by the total number, which is this one here. So multiply by 2928 like this. So it actually get, so you don't have to simplify from head, because this is paper 2. If you're doing calculator version, then you just expect it to just use your calculator and then get 1830. So 1830 rooms. So calculate the cost per day of an executive room. So we're continuing in our modeling here. See, you want the cost per day for an executive room. So you can just, before doing anything, just let the cost. You can even say the required cost to save time. So let the required cost be X. Okay, so if it's X, what do? You say to get the total value, the total money here, what do? We say the required cost per executive room, okay, multiplied by the number of rooms for executive. So the number of rooms for executive would be 2928 minus this one's for general. Okay, 1830. Then we're going to multiply this by X. Then plus what? We're given this one we had calculated as 1830. So 1830 multiplied by 19 here, because it's $19 per day per general room. Okay, so it's equal to 66,612 like this. So what you do is here you can just simplifying steps. So 2928 minus 1830, then you get 1098. And as we are doing it, just remember that oftentimes the way that you can know if you're doing the right thing is you have to check whatever answer that you'll be getting. Exact answers, usually they're very encouraging. It's very rare that they actually give you answers that are sort of like bizarre. If you're getting, let's say, 25 over 31 or something like that, those are really rare answers. I'm not saying that it doesn't happen, but I'm just saying that it's very rare. Okay, so over 1098 here. So you can actually go to your calculator, and then the way that you do it, if you're not really good with calculator, you can compute the whole thing if you're good. But then if you're not really good, what you do is put in steps. Okay, so you put the numerator first, and then after putting the numerator, then you say divided by the denominator, which is, then you get 29. So it's actually $29 like this. Okay, so this is mathematical modeling. The way that you actually get good at this is if you do more and more questions. And then notice that this was a question that was linking the idea of ratios, which we used the simple proportion, and also the idea of consumer arithmetic. Okay, just crunching numbers. So let's move over to the next question. Next question says, you have this matrix. So this is one cell here, one cell, one cell, one cell, and then you're asked to determine the determinant of the value of the matrix A is less than 7. Okay, you're asked to find the largest value of A. It was supposed to be largest value of A. So how do you do it? Just do the same way that you do to find the determinant. Okay, so determinant, you can either say dt of A, or you can actually just say A here, then you put between bars. It simply means determinant. So what you do is this diagonal here, they have to multiply first. So the way that you do it, since this one it's a train, you put a train in brackets. Okay, and then this one, you put minus first, then you put this one. Just be careful. Most students, they actually get wrong. What they actually get wrong is the signs. Okay, so sometimes there's negative there, and then you don't know that this negative is generic. This negative here, it's generic. Okay, it's always there. So you have this, you're told that this is less than 7. Now you simplify. So here you can actually expand to say 3x plus 6 minus 12 here less than 7. So you get 3x less than, here you'd get negative 6 here, 6 minus 12, you get negative 6. And if you're having a hard time understanding why 6 minus 12 is negative 6, just put in the comments in the comment section, and then I'll be able to do a video on that. But essentially 6 minus 12, 12 is a bigger sized number in terms of magnitude. So the answer would take the sign of the bigger sized number. So the answer would take negative, and then you just say bigger number minus smaller number. This is called the different signs rule. So 6 minus 12 minus 6, you get 6. Then answer takes negative, so it's negative 6. Okay, so if you want, you can actually say negative 6 here so that I don't confuse you much. But those steps, they don't actually have any marks. So for example, here I can just write directly 13, because 7 plus, when you transpose negative 6, it becomes 6 positive. Okay, so you have 3x less than 13 here. Then you just divide by 3, both sides. So you have x less than, this one you get 4 and a third. Okay, so you asked find the largest value of A. Okay, it was supposed to be largest value of x here. What was I doing? So it was supposed to be largest value of x. So here you would say x, the elements of x, they're equal to what? So you can actually write this way in set notation, I think. So it would be less than 4 and a third. So it'd be 4, 3, 2, and so forth. Okay. So the greatest value would be 4 here. So determinant equal to 4. Okay. So we're given this diagram. So part B, we're given this diagram. It's a vector. it's a vector question, so you're given PQR like this. It's a triangle, and in the diagram PQ is equal to 3x, just like how it's labeled here. This one is equal to y, and notice that the y they actually put between Q and W. This is how you'd interpret it. Okay, so if y is put in between Q and W, it means that y is vector QW. Okay, if y were vector QR, what they would do is that they would put the arrow here. So they actually don't do that for that reason. Okay, so they want you the same information that you're given at least on the spot, you can actually read it off of the graph just by studying the way they write. So n is the point on PR to make Pn equal to nr. Okay, so Pn here it's equal to 2nr. You can actually write 2nr. You see why this will be useful. And then this one would be what? Would be nr. Okay, so essentially they're just telling you that this is 2:1. Okay, maybe we'll use it later. So you're asked to find QR. So QR is a vector. So QR you can either essentially when they tell you find vector QR, they want you to write the vectors for any path that leads from point Q to point R. So you can actually go from Q to P. So it will be QP plus PR. But then the problem is that we don't know PR. Okay, so what you do is use this path instead. So this path says QW plus WR. Okay. Now the problem is we know QW, but we don't know WR. So how do you do it? Here you're told this ratio here. It's a decoder, okay? So you have QW over WR here. This is what the ratio means. It's about 1/5. So you can actually just cross multiply these ones. You can give them directions. They're going in the same direction, so that's why they're positive. So you can cross multiply and then you get 5 QW equal to WR like this. So you can actually say QW here plus WR. You can just substitute this one, so it becomes 5 QW like this. So QW plus 5 QW, you get 6 QW. Okay, then QW is what? Is Y. So you get 6Y here. So write it down somewhere so that I'll be able to use it in later questions. Okay, let's move on to the next question. It asks us to find PR. So PR, how do you find PR? So you just pause the video and then see which path you'd use. Obviously it'd be this. Okay, so PQ plus QR. And the beautiful thing is you now have QR. Okay, we just calculated QR. So PQ is equal to 3x, as you can see here. Then QR is equal to 6y. This is it. If you want, you can. So this is your PR. Write it down somewhere, okay, so that we'll be able to use it. Next part asks us to find PN. So PN here. So we have PR. What we have is PR, and we know that PR is equal to PN plus NR. Okay. So from here, what we can deduce. So you can say from PN equal to I can just say without putting this vector. So 2NR from this. Okay, without putting this vector again. So from this, you can deduce that NR is equal to half PN. Okay. And then here you can put vectors. If the magnitudes are like this, then you can actually put the vectors as long as they are going in the direction, same direction. N to R, P to N, they're in the same direction. Okay, and then you're given this. So what you do is substitute this one, Pn you now have. So it's Pn plus half Pn. Okay, those are vectors, and then you get 3/2 Pn here. So you can now actually multiply both sides here. Let me use a different pen. So you can multiply both sides by 2 over 3 by 2 over 3. Okay, why are we multiplying by 2 over 3? Because we want to get rid of this. Okay, so that we are just left with Pn. So Pn is equal to 2 over 3 PR, like this. So it's equal to 2 over 3. Then our PR we had calculated previously as 3x plus 6y. So Pn is equal to, this one is separate, okay. So Pn is equal to, we can divide by 3 first. If you are good, you can actually do this in one step, but you can divide by 3 first, so you get 2, then you get x plus 2y, like this. Then you can multiply throughout, so you get 2x plus 4y. So this would be our answer. So 2x plus 4y, like this. Okay, so the trick is just knowing exactly which part to check, and also using these decoders that you're given, these decoders here. So the way that we use this one is we found, because our Pn, we knew that that's what we wanted, and then Nr, that's what we wanted. That's why we had to get rid of. So we got rid of Nr from this ratio here. Pn equal to 2Nr is the same as our vector Pn equal to 2 vector Nr, like this. So as long as they're going in the same direction. And then afterwards, obviously, you isolate Nr, then you substitute Nr here. You condense this one, 1 plus 1 half, you get 3 over 2. So you get this one, and then you multiply, you have to get rid of this so that you're left with Pn only. So Pn is equal to this, then we substituted from our previous our question. So let's move on to the next part. So we have a psychogeometry question. So in the diagram, PQ, R, and S, they are all points on the circumference, okay? So this is a cyclic quadrilateral, and POQ is a diameter of the circle. So POQ, so this one is a diameter. And whenever you're given a diameter, obviously, you have to look for the sweet angles here. So this is supposed to be 90 degrees, okay? Angle formed at the circumference from the diameter, it's equal to 90 always. So arcs, this and this are equal, so this ones and this ones are equal. So they also subtend the same angles, by the way. In the same way, let me actually see, I'm very lousy drawing, but let me attempt this. So if you have the same chord here, if this is really terrible drawing, but I'm sure you get the point. These angles here must be equal, okay? So because they are subtended from the same chord. So in the same way, you can have them separately as long as they are the same size. They don't have to be the same chord as long as they are the same size. They're all the same. Okay. So it says name the angle which is equal to SQR. So SQR is this angle here. Okay, let's call it theta. The angle which should be equal to SQR would be this angle here. Okay. So why? Because they are subtended from the same chord. It's not the same chord, but then the chord has the same length. It was similar to the previous case that I was explaining to you, except now instead of just having one chord, you'd actually have 2 chords, but of the same length, so it would serve the same effect. Okay, so here it'd be, so this one must be P then, QR is here, so SQP. SQP, then find PQS. What is P, Q, and S? This one here. We'd say this one is 90 degrees. So now we just have to say 90 minus 57. If this one is 90 degrees, that means that the 90 is already taken. So this and this have to share 90. That's why we're saying 90 minus 57. If that confuses you, you have to say 90 plus 57. Then you get 147. Then you say 147 from 180. Then you get this angle here. So you actually get 33. Okay, so 33 degrees. Then PQS, this is P, this is Q, this is S. Okay, we repeated the question here, so that's fine. So here 33, then QRS, so QRS, this one here. This one here, you have PQRS. This is a cyclic quadrilateral, so the opposite angles here, they must be complementary, so they add to 180. So you just have to say 180 minus 57, then you get 123. So this is supposed to be 123 here. So you get 123 degrees. Then QSR, this one here. So we'd say that this one is the same. So this one is 33 as well. So you say 33, 123 plus 33 equal to, then from 180, you get 24. So this is supposed to be 24 degrees. And then that's it. Okay. So 24 degrees, and then you're done. So the trick here was, this is actually a common question. So the trick was knowing that when the arcs, they are the same, the chords are also the same, and the angles that the chords subtend on the circumference, they're also the same, and then done. Okay, let's move forward. This one says the diagram, it shows an arrow of a signpost. Okay, the arrow is cut from a rectangular sheet of metal, dimensions 30 centimeters by 20 centimeters. So this rectangular sheet here, this is what we started with. Okay, so this whole sheet here, this is what we started with, and then they started cutting out this part, this part, this part, and this part. That's what they're telling us. You are told to calculate the area of the arrow, so you can actually divide the shape in as few sections as possible. Okay, so we can actually do for this A and B. So for A, it'd be easy because we have 15 here, which we know of, and we just have to find the length here. So this is 7, this is 7, that's 14. The total is 20. So here must be 20 minus 14, which is 6. And then here we also have to find the base for this. So the base for this one is 6 up to here. Okay. So the base for this triangle, so that we can say half base times height. Okay. The base is 20, obviously. So this is 20. You can actually write here. So this is 20 here. Okay. So we're good to go. So area is equal to area of A plus area of B. So you can even say area of triangle plus area of rectangle. So area of A is equal to 15 centimeters by 6 centimeters plus area of B. Area of B is equal to half base, which is 20, by height. The height here is given as 15. So by 15 here. Okay, you can put centimeters here. If you want, you can just put 4 for the answer. You get 240. So the units for area, they're square units. Okay, so we're dealing with centimeters here, so it must be square centimeters. And then you're done. And then calculate the perimeter of the arrow. So the perimeter, I just find one spot to start on. So perimeter is the distance or the length right around a shape. Okay, so we're going to move here to here. That's 15. We're going to move from here to here. That's 7. Okay, we're going to move from here to here. Let's call this x. Let's call this x again. Okay, x and x, they're the same. So plus 2x here, plus 7 again, plus 15 again, plus 6. Okay, so you can actually add everything else here to say 15 plus 7 plus 7 plus 15 again, the symmetry, right? Then you add 6 here, then you get 50. So 50 plus 2x. Now the burden is finding x here. This is a rectangle triangle. Okay, how do we know? The section was cut from a rectangle, so obviously this projection here must be a right angle triangle. Okay, so here we know that this length is 15, this length is 10. So x squared must be equal to 15 squared plus 10 squared. This. So x must be equal to square root of, you can actually just type 15 squared plus 10 squared 325. Okay, so this is 325. So you just use a calculator, you get 325. So you can actually go back here and then write it. Okay, so here would be 50 plus 2 square root of 325, like this. Okay, so you have to write the answer. If they ask you to leave this answer in set form, you can see that 25 is a factor here. Okay, so what you do is 325 will be equal to 25 times something. So you can say 325 divided by 25, then you get 13. So 25 times 13 here. So square root of 325 is equal to square root of 25 times square root of 13. So it's equal to, this one will be 5, square root of 13. Okay, this one you can write it as square root of 25 times square root of 13. So you know square root of 25 already. Square root of 13 you can't know. So you'd actually get this instead, in set form. So that means that for this one, now what you get is 50 plus, this is 2. So 2 times 5, you get 10. Square root of 13, like this. You can put in big brackets, then you put your units. So centimeters. So 50 plus 10 square root of 13 centimeters, okay? Like this. If they want it exact, non-exact, you can just say here on the spot, you can just say 50 plus 2 square root of 325. So yeah, then you change it, it'd be 86.1. Okay, 3SF. It would still be the same answer. I'm just telling you this just because sometimes they ask you to leave in said form. Oh yeah, so that's it for today. Our questions are done. Make sure you like, share, and subscribe. You go out.